today we're just going to recap some of the rules that we learned in our last lesson. So given the formula for the graph of an absolute value function, we have a couple rules that we discussed. Rule number one is if the a value at the number in front of the bars is bigger than 1, so like if it's 2, 3, 4, 5, etc., what you're going to have is a graph that has been vertically stretched. Now, because that's a new phrase for us, it's a good idea to draw a diagram of what the heck that actually means. So if you have just a regular V, it's going to make your V get closer together. So it's look like it's closing up a little bit. So sometimes that confuses kids because they're like, yeah, but it's shrinking, it's getting closer. From a horizontal standpoint, yeah, it is shrinking. But when we're talking from a vertical standpoint, it is stretching. You can see that these lines are getting pulled up further away from the x-axis. So it is a vertical stretch when it gets skinnier. Right, and then the opposite of vertically stretched would be vertically shrunk. So if I put like 1/2 in front of the bars, or 1/3, or 1/4, etc., it's going to cause your graph to get vertically shrunk. And again, because that's a new phrase, it's a good idea if you draw a picture of what that looks like so you can see that that will make your V get wider. Now, if you have a minus inside your bars, that means you're going to go right. And if you have a plus, that means you're going to go left. So it's opposite of what you think. Most of us think minus means go left and plus means go right. But when you're talking about shifting rules, anything that's inside the bars, it's opposite of what you would think. So you have to really watch out for the whole right and left thing. It's opposite of what you would think. Next rule is if you have a negative in front of your bars, if you have negative in front on the outside, that's going to make your V go upside down. So we call that reflecting about or across the x-axis. Now whatever's on the end, it might say +2 or -2 on the end here. So whoever's in K spot, if that is a positive number, that means we're going to go up. And if it's a negative, we're going to go down. So I always tell my students vertical manipulations will occur outside of the bars. So any numbers outside of the bars have a vertical transformation to them. Anything that's inside is a left and right horizontal thing. So what we're going to do is we're just going to take some formulas and we're going to decide what each number is going to do to our V. So right here you have your absolute value of x, that's your basic V. If I throw a 3 and a 2 into it, the goal is to know ahead of time what to expect from your graph. What's your graph going to look like before you even graph it? So I'm just going to go in order of what I see. I see that 3 in the front first. So because 3 is bigger than 1, that's going to be a vertical stretch. And not only do you say vertical stretch, but you have to tell me by how much. So you would say by a factor of 3. And if you want to shorten that, you can just write BFO, 3. So you got to tell me everything. You got to tell me that it's a vertical stretch, and then you have to tell me who is the factor, by a factor of 3. And then that +2, because that is outside of your bars, that means you're going to go up 2. If it was inside of your bars, then it would be a left or right scenario, but it's outside. Letter B, we have a negative out in front. So according to our rules chart, that means it's going to take your V and it's going to turn it upside down. Then we deal with the fact that you have a 1/2 in front of your bars. Because 1/2 is smaller than 1, that's going to make your V get wider. And that's called a vertical shrink by a factor of 1/2. So you have to tell me all of that in one line. And then we want to address the +4. Because that is inside the bars, it means we either go left or right 4. Plus means go left. So we're going to go left 4. So those are the things that are going to happen to our normal V, and what we have left over, that's the graph of that function that they wrote. And then we keep going. So letter C, I see the negative on the outside. That means it's going to flip upside down. The -1 that's inside is going to make it go right 1, and the minus on the outside will make it go down 3. Right, letter D, that +2 is inside, so we go left. The -6 is outside, so we go down. And then letter E, because 5 is bigger than 1, that's going to cause our V to get skinnier or vertical stretch by a factor of 5. The -2 outside means we go down 2. And last but not least, letter F, we see the 1/3 out front. That means it's either going to shrink or stretch your graph. Because it's less than 1, it's going to be a vertical shrink by a factor of 1/3. And then our +1 means left 1, and our -2 means down 2. So the good news is all of these, like shifting left, right, up, down, stretching, shrinking, upside down, all of these rules are consistent with each function that we do. So once we move into, let's say, the quadratics, these same rules will apply to those functions. So the movements are going to be consistent, which makes this a little bit of an easier task as we go down the road. So what we're going to do is we're going to take our knowledge of transformations and we're going to go ahead and graph these without needing to rely on a graphing calculator or Desmos. So normally our V would start at 0, 0. That's where the point of the V would be. Because it says +2 inside, I need to move to the left 2, and then I need to put a dot. Okay, now because there's no number in front of the bars, I'm free to just count my normal up 1 over 1, up 1 over 1, and so on. Make your nice pretty V. Now number 2, again, the plus means we're going to go left, but you notice there's a negative outside your bars, so your V is going to be upside down. So instead of going up 1 over 1, I'm going to go down 1 over 1, and so on. Now look at number 3. There is a 3 out front, but that 3 indicates a stretch, a vertical stretch. There's no pluses or minuses, so there is no shifting. That means you're going to put your dot at 0. Now from there, instead of going up 1 over 1, you're going to go up 3 over 1. So you can see that makes your V a little skinnier than what it typically is. All right, number 4, we do have some shifting. You see the -2 inside the bars. That means go to the right 2. And then we're going to count our new slope. It's not 1 anymore. It's not up 1 over 1. It's up 2 over 1. Because we have to vertically stretch it by a factor of 2. In number 5, there's no numbers being added or subtracted inside, so I do not go left or right, but I do have to go down 3 and put my dot. And instead of going up 1 over 1, I go up 1 over 2, and that's my new V. And then last but not least, number 6, I will have to go to the right 1, but up 2. And my slope is going to be up 1 over 3. And then connect it. All right, so take a minute, go ahead and pause the video and see if you can graph these 3 on your own. See if you can use those rules and try to make your own graphs. And then when you're ready, you can unpause the video and the answers will be up. All right, go ahead and take a look at your shifting, and did you increase your slope? 2 of these should be upside down. And then like I said, those rules will be consistent across different kinds of functions, so you'll get plenty of practice doing that. This is just kind of an intro into the rule. All right, last thing that I need to show you is how to get your vertex given an absolute value. Now you have not done any problems where there was a number right in front of x here on the inside. See how x was all by himself in here? It just was x minus 3, x plus 1, x minus 2, but this is 2x plus 1. So a lot of kids, if asked to graph this, they'll say, oh, go left 1. You do go left, but it's not by 1, and it's all because of that 2 that's right there. So we're not going to make you graph this, but I could still ask you, hey, where would the vertex be? If I made you graph it, how far over would you have to go? So all you have to do is take what is inside and equal it to 0. And when you do that, you'll get your vertex or your h value. So I figure we'll do that 3 times, and that'll kind of get you the idea of what we're doing. So I take 3x minus 4. By equaling it to 0, whatever I get for x, that is my h value. So it's going to be, if you add the 4 and divide by 3, 4/3, and you can just leave it like that. Fraction form is fine. Similarly, 5x plus 2 would have to equal 0, which would get me an answer of negative 2/5. So that's where my h value would be. And then letter C, if I solve it, I'm going to get 1/3. So that's going to conclude our topic on graphing V's, absolute value functions. Our next lesson will look at what's called quadratic functions.